Welcome! We're Group 6, formed by Eliezer Montes, Leonardo Rivas, and Alina Tutuyano. Our main project for the next 2 semesters is going to be a 3D printed prosthetic hand. Hope you guys enjoy. The main problem is that 185,000 amputations occur each year at the United States. But according to Rachel and her colleagues at the University of Washington School of Medicine, only 56 of those with an upper limb amputation use prosthetics for an average of 11 hours per day. That means it really forms part of their life. Most of the amputees do have a prosthesis, but they find it rather uncomfortable and hard to control, making our challenge a way to develop a prosthetic limb that feels comfortable and natural at an affordable price and should resemble as much as possible a real limb. Another challenge that we're having and facing in today's world is that a prosthetic limb can cost anywhere between $15,000 and $90,000, depending on the type of limb desired by the patient. It means it's not affordable. It is not reachable for anybody who lost a limb and is in need of one. Using 3D printers, it is possible to manufacture a single individualized product without having to have metal molds, thus reducing the cost drastically. And weight as well. There are open source initiatives like the Open Prosthetics Project, Open Bionics, or Enable that try to advance prosthetics technology while attempting to lower the cost of these devices. There will be more research and development needed to be done on 3D printed robotic prosthetics hand. It is the next future for that medical field, and it's within our reach to try to do it for our project. There is a numerous amount of prosthetic hands out there, different materials, different technologies, weight, and uses for different patients. But we're going to focus on 3 types. The first one is body power arms, which uses a harness system to control a specific body movement. They're durable and less heavy compared to myoelectric ones, but they are only able to be used by a specific type of patients, the patients that have a limb that has some kind of movement. That movement is used to open and close a hand by transferring that movement. These are cost effectively. The next one is the myoelectric arms, which utilizes the residual neuromuscular system of a human body to control the arm. Electrodes are applied on the skin to control the movements of the prosthetic. Longer training is required since the patients will have to learn how to contract the muscle and understand how the process works in the arm to open and close the hand. The next one is the robotic arm. It uses biosensors to detect signals from the user's nervous or muscular system. It sends information to a microcontroller embedded into the arm, which processes the information and controls the arms using actuators. DARPA usually finances research to create artificial limbs that ties directly into the nervous systems, which means most of the time they will require surgery and means that the arm will be one of the most expensive ones. The solution to all this is to develop an open source 3D printed prosthetic arm that uses an Arduino microcontroller, materials which are available to any user, and receives a process of information coming from electrodes attached to the skin and controls the arm according to the incoming signal. The design should be available at a platform that anybody can access and where they can get simple and explicit instructions on how to recreate the arm for personal use and receive feedback if needed. The main goal and objectives for fall 2018. It is to develop and enhance the 3D model of a hand, design the schematic circuit for the robotic hand, find the right components that will be implemented to robotic hands, such as motors, microcontrollers, batteries, These have to be easily available to any patient that needs them in the future. 3D print the hand, assemble the circuit, troubleshoot it, integrate the arm with all the circuitry, develop a software that takes an input from the muscle response sensor, the wearable sensor actually, and controls servo motors in order to move the hand, testing the first prototype and revise the design. The member's responsibility would be that Leonardo would design and print and assemble the 3D model of the hand. Lister design and assemble the circuitry, and Alina design and implement the software. As a whole group, we would provide ideas, find components, and integrate and test and revise the hand. With this, we conclude our presentation of our robotic hand for fall 2018. Thank you very much.